look at it and throw something together. It's going to be wrong. You've got to look at it and say, what do we have given in the picture and what do we know about the picture to set up a true statement? Did you hear all the notes I said? So there's a lot of notes out there that don't know how to do this. So you should all be watching, maybe even taking notes. Okay, we have these two parallel lines and we have this transversal cutting it. Now guys, remember back to when we learned this. When we have two parallel lines and a transversal, it creates a bunch of angles. We have alternate interior, alternate exterior, consecutive interior, corresponding, and vertical angles, right? Okay, so we know different things about those types of angles. So with this one, I saw a lot of yeses as well. What kind of angles is 2x minus 3 and 3x minus 5? Corresponding, they both sit on the same side of the transversal. They're both on the right of the transversal and on top of the parallel line. So they're corresponding, so they are what? They're equal. So a true statement would be to say, why did that stop writing? Okay, so a true statement would be to say 2x plus 3 is equal to 3x minus 5. Now, guys, if you have questions on that, I am trying to figure out, maybe I'm not explaining it well enough. I'm trying to figure out what doesn't make sense about that. I don't understand, so help me understand. Does that make sense on how that's a true statement? Pinky promise. Okay, then you guys got to start getting them right. Okay, what about this thing? What about these two angles right here? This angle and this angle, what kind of angles are those? Vertical angles, very good. So would it be true to say what about vertical angles? They're equal, good. So 19 is equal to 3x minus 5. Okay, so those are two true statements, and then we could solve for x. I'm not going to in this one, because really you guys should know how to solve for x. I think you're pretty good at that. It's just setting up the true statement. Does that true statement make sense to everybody? Okay, so we got to start getting these right. You're going to see them on the end of level tests. You'll see stuff like this, very much like this on the ACT. You guys have got to be ready for it, okay? All right, that was a good one to re-go over. Okay. All right, so today we're doing 3-1. It's the first unit in probability. So we're going to shift gears. Probability is way different than all this math that we've been doing. So we're going to be shifting gears for a unit. Some of you, it'll be a nice break, but probability can be pretty difficult. I'll be honest with you, okay? Probability is one of the hardest maths for a lot of students. It tends to be one of the hardest maths for me. It just depends on who you are. But probability can be really fun because there's a lot of relatable problems in the real world, and a lot of students actually really like probability. So anyways, that's what we're doing in this unit. So this is 3-1. So today we're going to be doing probability with area models, and we're going to be dealing with independent events. So I'll explain what I mean by all of that in just a second. But just to recall, we have seen probability once this year. It was just a quick couple practice problems on very simple probability. So remember that probability by definition means the likelihood of an event to occur. Once again, probability means how likely it is for an event to occur. Now we see probability in two different ways. We'll see it as a decimal, and then we know that that decimal can be converted into a percent. So we'll see probability both in decimal form and percent form. So this is the decimal, and then this is the percent of that same decimal. Now notice, if you don't know how to change from decimal to percent, you'll take your decimal and move it 2 decimal places. So does everybody see how this is 2.5%? 0.025. Did you see how I took my decimal and moved it 2 places, giving me 2.5%? You're going to have to do that today. You're going to have to be able to do that with probability. Because really, probability in the final answer will usually be stated as a percent. Not always, but more times yes than no. All right, now 0, if you get 0 as a probability, that means it won't ever happen. And if you get 100 as a probability, it's 100% likely to happen, guaranteed to happen. So just understand, we're going to be bouncing between 0 to 100. We're not going to be going over 100. Because 100% likely means it's guaranteed to happen. 0% means it's never going to happen. So we're going to be, all of our numbers are going to be from 0 to 100. Now in decimals, it will be from 0 to up to 1. So decimals in between 0 to 1. Because 1 is 100. It's the office, so I got to answer it. Okay, continuing. Okay, right, so now once again, still with probability, I just said it is the likelihood of an event to occur. Now, if we're not given the individual probabilities, we can calculate the probability by taking the number of outcomes that we're desiring divided by the number of total possible outcomes. So really the number of outcomes over the total number of possible outcomes. So that's how you can find probability, by calculating it by hand. So for example, if there was 100 marbles and we picked 25, that would be 25 out of the total. So 25 out of 100, so we picked 25% of the marbles. So that's just an example of how probability will be seen. Does everybody understand how that probability works? The number of outcomes over the total possible outcomes. Okay, so that's how you can calculate probability. Questions on that? All right, now independent events. There is a huge difference between dependent events and independent events. So with probability, we're going to start out these first few lessons with independent events. And what an independent event means is the occurrence of one event happening does not affect the outcome of the second event happening. So I'm going to say that again. Independent events, the occurrence of one event happening does not affect the outcome of the second event happening. So once again, the first event doesn't change the likelihood of the second event. So here's some examples of just what an independent event, what two independent events would look like. So if I was tossing 2 coins, these are independent events, because if I toss this coin, this silver coin in the air, it's going to either land on heads or tails, right? Everybody? Okay. Well, is that going to change the fact that if I toss this penny, it's going to land on heads or tails? No. Like tossing the first penny, the first thing here, is not going to affect when I toss the second thing. So these are considered independent events. Does that make sense? How they don't affect each other. Okay. Here's another example of independent events. If I had a little bucket, very good bucket. I actually have a minor in art. Just kidding, I really don't. As you can tell. Because that's a horrible drawing. Anyways, but so I have a bucket of Twix, Reese's, and a Twix. Now, if I was to draw one of these out and then put it back in, is it going to affect if on my second draw, if I'm going to get a Twix, Reese's, or Twix? It's the same as the first, right? If I put it back in. So if I draw out a Twix and put it back in, and I go draw again, is the likelihood the exact same as the first time? So the drawing out, if I replace it back in there, it's not affecting. They're independent events. It's not affecting the second one. But here's the important thing. If I drew out a Twix, so if I said to you, what's the probability I'm going to draw a Reese's? Well, there's only a 1 in 3 chance I'm going to draw a Reese's, right? Okay, now let's say I go in there and I draw a Twix. I pull out a Twix. Now, if I did not replace it, would that change my likelihood of my next draw on getting a Reese's? Yes, right? Because it's a 50-50 chance now, if I don't replace that Twix, that I'm going to draw a Reese's. So that would be considered dependent events. We're going to be dealing with independence today. So with replacement, it's independent. All right, and then here's one last example of independent events. If I was spinning 2 spinners, so let's say I took my hand, spin this spinner, went around, landed on 4. Is that going to change the fact that, is that going to change the likelihood of me spinning this spinner and landing on blue? Do they affect each other at all? No, right? So these are examples of independent events. We just got to understand the difference. So I think you do. Any questions on independent events? All right. So here's the rule. This is your first rule, okay? If you have probabilities of 2 or more independent events, then you can find the probability of both events happening by multiplying the individual probabilities. So that's your first rule. So once again, if you have the probabilities of 2 or more independent events, you can find the probability of both events happening by simply multiplying the individual probabilities. So we'll take the probability, and you're going to see it denoted like this, meaning written like this. So the probability of event 1, this P, comma, and then what was inside what we're taking the probability of. So the probability of event 1 times by the probability of event 2. If they're independent events, this is how we can find the probability of both happening. And that's all we're learning today. So now we're just going to apply it. So I'll give you a second to get that down. Then we'll just get to our first few examples, and then really I'm just going to let you work the rest of the time after we do a few examples here. While you get that down, just a couple more things. So I am going to teach you one more thing. Just a way to model probabilities. So like I said, we're learning area models today. So the rule is this is the only rule we're learning today. We're just going to learn how to make an area square to really easily see the probabilities. Okay, am I okay to go to the next slide, everybody? Almost, not quite. Just be honest. It's fine for me to wait a second. Is there still a few people writing? Okay, awesome. All right, let's move on. Okay, so we're going to be dealing with area squares. Area squares, they're not a rule or anything. It's just a way to model the possible outcomes of two events, along with their probabilities. So we're just going to learn how to draw these area models because I use them all the time. You will see them on the end of level. I saw so much probability on that end of level test, and I saw tons of area squares. So this will be really good for you guys. Okay, so what you'll do is you'll set up your area square like this. On the top, you'll do the possible outcomes of event A of one event, and then on the other side, down the running side, you'll do the possible outcomes of event B, or the second event. And then inside, what you're going to do is you're going to list the probabilities of where they both are happening. So once again, these will be where your probabilities are. And then it's really easy because they'll start asking you questions like what's the probability of event A and B? And then you can just look at your area square and quickly tell the probabilities. Now understand something, guys. With these probabilities, inside here will add up to be 1. Okay, so inside here is going to add up to be 1 because it's only 100% total. That once we get all of our individual probabilities, it can only add up to be 100% total. So the inside here, you can always check and say, okay, does that add up to be 100%? Or if you're dealing with decimals, then you'll say, does that add up to be 1? Because it should, and it will, if you've drawn your area, your probabilities correctly. Okay, questions on that? Now, I know that you're still like really rusty. You're like, I don't really get what we're doing here, but I can't show you without just showing you how to draw these. So we'll just do our first example, and then you'll be good with area squares. Okay, here's our first example, guys. Now, it's going to be really hard for you guys to take notes because it's just, I mean, you can the best you can, but if you need to just take a picture at the end, that would probably be best. Just because it'll be, you honestly will understand it better if you're not trying to write this down, but like listening and watching. Okay, so it says, the probability of women that like Diet Coke at RHS is 70%. The probability of women that like Twix is 40%. Now it says, draw an area square that represents the two events. So first of all, my first event is women that like Diet Coke, right, everybody? Is everybody following me? Women at RHS that like Diet Coke. So I'm going to do that across the top. I'm going to write Diet Coke. Now, my second event is people that like women that like Twix. So I'm going to write Twix. So I have Diet Coke and I have Twix. Now, if you read it again, it says the probability that women like Diet Coke at RHS is 70%. So they either like it, yes, or they don't. So yes or no, they like Diet Coke or don't. Does everybody understand what I just did there? Yes or no, they like Diet Coke. Okay, what's the probability that they like Diet Coke? 70%. So it's 70% likely that they're going to say yes. Well, if that's the case, how many do not like Diet Coke? 30%. What is it? 30%. How do you know that it should be 30? Because it's 170. Good. It equals 100%. Very good. So once again, same thing with Twix. It's either yes or no. I should have not drawn that line yet, probably on Twix. Or even on Diet Coke. That's okay. All right. So Twix, it's either a yes or a no. So yes or no. Now it says the probability of women that like Twix is 40%. So that they do is 40%. And that they don't is what? 60%. Okay, questions right there. So now I'm going to go ahead and I'm going to draw my lines so that I have my area square. So we have yes or no separated. We have yes or no separated here. This wasn't the prettiest area square. All right. All right. So then, guys, now if you look at your area square here, this would be, right here would be yes and what? Yes and Yes and yes. Okay. And then this would be no and yes. So no and yes. This would be yes and, so yes and no. And this would be no and no and no. Okay, are these independent events? Did it say anything about one affecting the other? No, so they're independent events. So we can just take and multiply their individual probabilities to figure out what's going in the squares. So if we want to know the probability of yes, we'll take our 70% and multiply it to 40%. Those are multiplying the individual probabilities. To find the probability of yes, yes. So you'll take out your calculator. Now it's important that you type it in as decimals. So 70% is 0.70. So we're going to do 0.70 times 0.40 on your calculator. Everybody practice it. 0.70 times 0.40. 0.28, right? So that's 28%, right? So that's 0.28, which is 28%. So in here, I'm going to write 28%. So the probability, guys, that they like Diet Coke and they like Twix, women at RHS, is a 28% chance. So let's do that they don't like Diet Coke, but they do like Twix. So you'll multiply the individual probabilities. So you'll do 30 times 40. So you'll type it in, 0.30 times 0.40. 0.12, which is 12%. Very good. So there's a 12% chance that they do not like Diet Coke, but they do like Twix. And then yes and no. So you multiply those individual probabilities. You'll do 0.70 times 0.60. 0.42, so 42% chance. Good. And then once again, they don't like Diet Coke, they do not like Twix. What is it? 18.18, which is 18%. Okay, I'm going to pause there. Questions on how I filled that area square in? Now that wasn't too bad, right? Okay. All right, so now let's find these probabilities. It says find the probability that women like Diet Coke and Twix. What's that probability? Look at your area square. How'd you know it's 28? So you're saying, okay, good. You're combining Diet Coke and Twix. Those are the only yes. Very good. So 28%. Good. All right. Any questions on how we got that? Now, what's the probability that women like Diet Coke but not Twix? So yes, they like Diet Coke. They do not like Twix. That's a 42%. Very good. Okay, do you have questions on why I chose 42 for that one? Okay. Okay, now looking at down here, what's the probability of liking at least one? So if liking at least Diet Coke or Twix, how would we do that? Yep, good. So we have this category right here. They do not like Diet Coke, but they do like Twix, right? So that's 12%. They at least like one. And then right here, they do like Diet Coke, but not Twix. So we'll add those up. So 12% plus 42%. Good. 54%. Okay, so at least 54% of the RHS school, at least one. Oh wait, but then if you think about it, so liking at least one, would we need to add the yes with the yes? Isn't that at least liking one? Yeah? So we also need to add 28%. I didn't even think about that. So at least one means at least they like one. So even more than that, at least like one, the 28% at least likes one. They like both. So then plus 28%. 82%. Okay, so 82% of women at RHS like at least Diet Coke or Twix. Very good. Any questions on that? So that's why the probability can be tricky, is you got to sometimes make sure you're reading the problem correctly. Okay, what's the probability of not liking either? What's the probability of not liking either? 18%. No and no. Very good. 18%. Okay, any questions on that? All right. Any questions? Okay, let's do one more. Okay. So it says, given two spinners where the probabilities are listed below, spinner 1, you can land on letters I, A, or U. So spinner 1, you can land on I, A, or U. And spinner 2, you can land on T or F. You can land on T or F. Now here are the probabilities listed. Landing on I is there's a 1/2 chance. Landing on A, there's a 1/3 chance. Landing on U, there's a 1/6 chance. Now on spinner 2, the chance of landing on T is 1/4. The chance of landing on F is 3/4. So we're going to draw an area model to represent the probabilities. So I'm going to call spinner 1 the top. Now these are the options: I, A, or U. Okay, any questions on how I did that? Now I'm going to list the probabilities off to the side. This is 1/2, right? This is 1/3, and this is 1/6. Okay, questions on that? Now I'm going to draw my lines down. Okay. All right, now on spinner 2, we can either land on, and I'm going to go like this. On spinner 2, we can either land on true or T or F. I don't necessarily know if it's true or false. True or false? What's the probability we'll land on T? 1/4. And then the probability we're landing on F is 3/4. Okay, so now I'm going to draw my lines. So now let's go through and put in the individual probabilities. So looking right here, guys, we're going to list all the possible outcomes. This is I what? IT, good. And this is AT, then UT, good. This is IF, this is AF, and this is UF. Okay, let's go through and put in the probabilities now. Okay, so to find IT, you would take 1/2 times 1/4, and I'm going to, since they started with fractions, I'm going to write it as fractions. 1/2 times 1/4. If you have to do that in your calculator, you would type it in with parentheses, but hopefully we can just multiply, well, I mean, if you use your calculator, that's fine. Okay, so let's multiply straight across, because when you're multiplying fractions, you can. So we get what? 1/8. Very good. So the probability of landing on IT is 1/8, and then we have 1/3, 1/4, so we'll get what? What's the probability? When multiplying fractions, guys, you can multiply straight across, so it's really easy. 1 times 1 is 3 times 4 is 12. Okay. And then multiplying this with this. So 1 times 1 is 6 times 4 is, so 1/24. Now we'll always want to put the most simplified fractions, but those are, so IF, we'll do 3 times 1, 3, and then 4 times 2 is 8. So 3/8. Wow, this is really small. All right, I'm going to give myself more room. I'm not writing very good. Okay. All right, and then right here, we have 1/3 times 3/4.
3/12.
3/12, but let's write the most simplified fraction, which is, good, 1/4. Very good. And then UF, we'll have 1 times 3, which is,
3.
so 3/24, which is, if you didn't know, you type it in your calculator, guys. 3 divided by 24. Change it back to a fraction, and then what? 1/8? Okay. All right. Questions on how I filled in my area model? Okay. All right. So this is what we have. I drew it pretty up here now so that we have some room. All right. So find the probability of A then T. You guys tell me. Hurry, tell me so we can finish and I can let you practice. What's the probability of A then T? A then T would be 1/12. Very good. Now tell me, do that in your calculator. What decimal do you get? What's the probability we'll land on A then T? 0.083. So what percent? 8.3%. You move the decimal 2 places to the right and you get 8.3%. Very good. Questions on that? Okay, find the probability of U then F. U then F. 1/8, and that is decimal 0.125, which is what? 12.5%. There's a 12.5% chance you'll land on U then F. Okay, this next one. This one's kind of trickier. Find the probability of landing on a vowel then an F. So the whole top's vowels. Yeah? And then this is F. So it would be this plus this, right? So add those up, and what do you get? 0.75. So what's the percent? So there's a 75% chance. That's a huge chance that you're going to land on a vowel and then an S. Okay, questions on that? All right, no questions. All right. This is literally my last example. It's a quick one, and then I'm going to let you work the rest of the time, and I won't bother you again. So last one, and then I'm going to let you work on the worksheet. So you are flipping 2 coins. So this one's different. That's the only reason I'm doing another one is because it is different in a way. And this is the last thing, and then I think you'll be good for the worksheet. So it says, you are flipping 2 coins. What is the sample space? So this one's a little less, it's a little less detailed, right? Everybody, it's a little less detailed. It didn't give us the probabilities. We just have to think about it. Okay, so you are flipping 2 coins. What is the sample space? So our first coin, we're either going to get a heads or tails. Very good. On my second coin, I'm either going to land on heads or tails. Now, once again, these are independent events because one does not affect the other. Okay, so here's my square. So right here, this is going to be landing on a heads and a heads, right? This is going to be landing on a tails, then a heads. This is going to be landing on a heads, then a tails. And this is going to be landing on a tails, then a tails. So there's a couple of ways of thinking about this. I'm going to choose to just do it like this. How many total possible outcomes did we have? 4. So total possible was 4. So we're going to use that number. That's why I'm showing you this one. It's different. Does everybody see that? The total possible is 4. So let's find the probability of flipping a heads and a heads. So look up here. How many times did we roll a head? Flip a heads and a heads? A heads and a heads. Once, right? The only place we flip a heads and a heads in a row is right there. And it's once. It happens one time out of how many? So 1/4. 1 over 4. Does everybody see how I did the probability on that? There's a 1 out of 4 chance. So that is a 25% chance of flipping a heads and a heads. Okay, let's find the probability of flipping a heads or a tails. A heads or a tails. It doesn't matter on order. It just said a heads or a tails, not in that order. So how many times did that happen? 2, right? A heads or a tails? Heads and then a tails, or a tails and a heads. So it happened 2 out of how many? 4. So there's a 50% chance, 2 out of 4, a 50% chance that we'll land on a heads or a tails. Okay, then find the probability of landing on the same thing each flip. There's 2. Good. This would be landing on the same thing. This would be landing on the same thing. This would be landing on the same thing. This would be landing on the same thing on each flip. So there's a 2 out of how many? 2 out of 4 chance that we'll land on the same thing each flip. So that's a 50% chance. Okay, last one. Find the probability of flipping a tails, then a heads. It does, order matters in this one. When does that happen? How many times? 1 out of 4. Very good. So 1/4. So there's a 25% chance. Okay, questions on this. Does everybody see how to do it? Do you feel pretty confident with probability? We're starting out pretty basic with probability today. Now, on your guys' worksheet, they draw the area models for you. I wanted to show you, though, because in the future, you might have to draw your own area model. Okay. All right, so now you can just finish the worksheet. Check with me as you go. Work together. There's just some good thinking on this. So work together. Ready, set, go.